Okay, so now we're going to look what we do when we are dividing instead of multiplying. It's the same idea, but when we divide a polynomial by a monomial, we will divide each term in the numerator by the term in the denominator. I'm going to highlight here for us each term. We can't just divide one thing. We have to divide every single term in the numerator by whatever's in the denominator. As we do this, we are going to use the quotient rule for exponents, which tells us that if we have two exponents with the same base, so a base of x, we will actually be subtracting their exponents. So I'm going to start by doing 12 divided by 3. And then I will do the x's divided by each other, and then I'll do the y's divided by each other. And I'm going to use the quotient rule each time. So 12 divided by 3 is 4. And then x to the 6th divided by x squared, I'm going to do 6 minus 2, which is going to give me x to the 4th. And then y to the 3rd, divided by y, that's like y to the 1. I'll do 3 minus 1, and it will give me y squared. So this is my final answer. Okay, so let's look down here. Like I said, when we are dividing, I have to distribute that 4x. I have to divide every single term. So I have to think about doing x squared divided by 4x, and then plus negative 36x divided by 4x. So I'm going to think about each term separately. Looking at my first term here, 16 divided by 4 will be 4. And then x squared divided by x. X squared has a 2, x just has 1. So 2 minus 1, I will be left with just 1 x left. Okay, when I divide my negative 36 by 4, that's going to give me negative 9. So I will write negative 9. And then x divided by x, that's just 1. 1 minus 1 is 0. So x, I could write like x to the 0, but I don't need to because that's just 1. It won't change the actual value of the term. So there is my answer. Okay, again, for number 2, I have to divide every single term. So 39y cubed divided by 3y. Plus negative 3y divided by 3y. Okay, so when I multiply 39 divided by 3, that gives me 13. And y cubed divided by y, 3 minus 1 will give me y squared. Negative 3 divided by 3, that's just negative 1. So I'm going to have minus. And then y divided by y, that's just 1, right? 1, an exponent of 1 minus exponent of 1 would be y to the 0. We know any number to the 0 is just 1. So my answer here, 13y squared minus 1. All right, next up, 50d squared divided by negative 5 plus negative 10d divided by 5 plus 15. Oh, those are negative 5s. Divided by negative 5. Okay, so 50 divided by negative 5 gives me negative 10. The d squared hasn't changed. Negative 10 divided by negative 5 is a positive 2. The d hasn't changed. And then 15 divided by negative 5 is just negative 3. And that's already in standard form. So that is my answer. Now I'm going through these kind of fast. Feel free to slow it down, go back and watch again. But our process is the same. We're just going to divide every term and think about it one term at a time. So this will be 28x to the 4th divided by negative 7x plus 49x to the 3rd divided by negative 7x. Minus 56x squared divided by negative 7x. I can actually think about that as plus a negative 56. That might make it easier to see what the sign's going to be. But on our first term, 28 divided by negative 7 gives me negative 4. And x to the fourth, divide x to the 1. 4 minus 1 will be x to the third. Okay, then I'm going to do 49 divided by negative 7. That will be negative 7. And x to the third divided by x, that's a 3 minus 1, gives me x squared. And last of all, negative 56 divided by negative 7, that's positive 8. And x squared divided by x, that's going to be a 2 minus 1, which will give me x to the 1, which is just x. It's helpful to me to write them out, each of them with pluses. Then I can figure out the sign after I've done the actual division. So I do plus and just leave the negatives with. Remember, the negative comes with each term. But my overall positive or negative will depend on what I get after I divide. Remember, a positive divided by negative is a negative, and a negative divided by a negative is a positive. All right, number 5. That will give me 40x squared y squared divided by 8xy minus, let's just do plus negative 8xy divided by 8xy. Okay, this looks more complicated, but we're just going to take it one variable at a time. So I'm going to divide the constants first. I'll divide the x's, and then I'll divide the y's. So again, we'll start with constants, then we'll divide x's, then we'll divide y's. So on the first one, 40 divided by 8, that's just 5. X squared divided by x, remember that's like having x to the 1. So 2 minus 1 will just be 1x. And y squared divided by y, that's 2 minus 1, that's just y to the 1. I don't have to write that y to the 1 because it doesn't actually change the value. All right, when I divide 8 by 8, negative 8 divided by 8 gives me minus 1. X divided by x is just 1, and y divided by y is just 1. So this term is actually just negative 1. And there's my answer. So something very, very complicated turns out to be something rather simple. All right, number 6. If at any point you feel like you're confident that you understand how to do this, you can go ahead and move on to the next video. If you get stuck, come back where you left off and watch some more. But the problems are going to just keep working out the same way. We're going to divide each term. Plus negative 68, a to the third, b to the fifth, 17a cubed, b to the fifth. Okay, and I'm going to think about it one term at a time. So I'm going to do my constants, and then I'll divide the a terms, and then I'll divide the b terms. And I will do the same thing over here. Divide constants, then a's, and then b's. And we kind of think about them separately. Because those are the like terms. So 17 divided by 17 is just 1, which I don't have to write because I'll write it just for fun. And then I'll have a to the fourth divided by a to the third. That will be 4 minus 3, which will give me a to the 1. So I'm not going to write the 1 because it won't change the value. And then b to the fifth divided by b to the fifth. 5 minus 5 is just 0. So b to the 0 is just 1. So I don't have to write it. So this whole term ends up just being a. Okay, and then when I do 68 divided by 17, I'm going to use my calculator here. I don't think that simplifies very nicely. 68 divided by 17 is 4. And it was negative 68 divided by 17, so that's going to be actually a negative 4. A to the third divided by a to the third, that's going to be 3 minus 3 is 0. So a to the 0 is just 1. And b to the fifth divided by b to the fifth will give me 5 minus 5, which is 0. So b to the 0 is also just 1. So my final answer for this whole thing, isn't it crazy how something so complicated can become something so simple? All right, next up, 16v to the third over 4v squared plus 8v squared over 4v squared plus negative v over 4v squared. Okay, so on this one, again, 16 divided by 4, that's just going to be 4. And v cubed, divided by v squared, will be 3 minus 2, which will give me v to the 1, which I won't write the 1, but because it doesn't change the value. All right, my next term, 8 divided by 4 is positive 2. And v squared divided by v squared, 2 minus 2 will be 0, so that would be v to the 0, which is just 1, so I don't have to write that. And then my last one, I'm going to have, remember, it's like having a negative 1. So if I do negative 1 divided by 4, I'm going to get minus 1/4. And this is v to the 1. So if I do v to the 1 minus 2, I'm actually going to get v to the negative 1. And right here, this term changes this. So this is no longer a polynomial. This is a different type of function because a negative exponent is not going to be a polynomial. But I can still write this. I'll have 4v plus 2. V to the negative 1 is like still just having that v in the denominator. So 1 over 4v. And this would be my final answer. Again, this is not a polynomial because we cannot have our variable in the denominator of a polynomial. Okay, we're almost there, guys. We're going to rewrite 12x to the 7th y to the 7th divided by 2x cubed y squared plus negative 8x to the 6th y squared divided by 2x cubed y squared plus negative 2xy over 2x cubed y squared. Okay, so when I do 12 divided by 2, I get 6. X to the 7th divided by x to the 3rd, 7 minus 3 is 4. And y to the 7th divided by y squared, that will be 7 minus 2, which is y to the 5th. Okay, negative 8 divided by 2 will be negative 4. X to the 6th divided by x cubed, 6 minus 3 is 3, so I will have 4x to the 3rd. And 2 minus 2 on those y's will give me y to the 0, which is just 1. So I won't write that because it won't change the value of my term. All right, last term, we're going to have negative 2 divided by 2, which gives me negative 1. And this one, again, I can tell I'm not going to have a polynomial because my exponents on the denominator are bigger than my exponents on the numerator, which means I'm going to end up with having variables down there in the denominator. If I do x to the 1 minus 3, I'm going to end up with x to the negative 2. And y to the 1 minus y to the 2 gives me y to the negative 1. These are going to go into my denominator. I like to write that as a positive exponent. Y to the 5th minus 4x cubed minus 1 over x squared y. And I'm not going to write the 1 because it doesn't change the value. But those negative exponents, remember, tell us that it is a reciprocal. Okay, last problem. A rectangle with an area of 33x cubed minus 44x squared plus 55x has a width of 11x. What's the length? Well, to figure that out, I will just need to divide 33x cubed divided by 11x plus negative 44x squared divided by 11x plus 55x divided by 11x. Okay, so that will give me 33 divided by 11 is 3. X to the 3rd divided by x will give me 3 minus 1 is 2, so x squared. Negative 44 divided by 11 is minus 4. And x squared divided by x will just be x. 2 minus 1 is just 1. And then 55 divided by 11 is 5. And x divided by x, so it would be 1 minus 1, which is x to the 0, which is just 1. So there is my answer. Okay, that was a lot of examples. Hopefully that helps you see what you're doing. I think you're going to mostly just need to practice this skill. There's a lot of spots to make little errors, so be very careful as you're dividing. that you remember to subtract those exponents using the quotient rule, and good luck.